Okay. Thank you very much, kind introduction, and also David, very interesting presentation is also cross-related today's topic. So it's my great pleasure to have a brief outline our SIP project and project D, and also after me is Professor Ikeuchi, project B. So we have collaborating in these two projects. So today's topic is a basin-wide smart dam operation. Let's say it's smart dam operation. How to utilize the existing infrastructure for the flood management. Not only flood management, for the energy transition as well. This is an important point. Okay, so I will talk about the 3 steps. First one is how the Japan is like a severe periodical flood is increasing under the changing climate. And how our society try to change our ideas, their operation rules, and existing infrastructure, how to improve. So recently, almost every year, we have periodical extreme flood. For example, in 2017 is in Kyushu, and 2018 in the western part of Japan, and 2019, Typhoon Hagibis attacking the metropolitan Tokyo area and going to the north. And also another 2020 is Kumamoto, is a very heavy flood occurs. And based on these conditions, government is upgrading their policy. I'm also work in the past in the government, Ministry of current MLIT. And also, especially for the dam engineering part, I work for the PWRI in Tsukuba. So they're also closely related to the dam engineering upgrading topics. So dam upgrading vision and post-disaster special panels also formed after the Western heavy rain events. And also, pre-release dam operation is David mentioned the advanced drawdown. Many terminology, but the same concept. How to more space needed flood capturing. And important point is river basin disaster resiliency and sustainability by all. I will talk about the next slide. And this is one example. In 2018, the western part is very attacking the severe rainfall and flood event. This is a case in Kyoto. After this seminar, these 3 key presenters, I will guide it to the Kyoto finally. And this is Katsura River, upstream Katsura River. We have one JW operated Hiyoshi Dam, multi-purpose dams. And flood is coming, and first or second peak is perfectly captured flood water. But finally, the third or fourth peak is almost full of water. So a more vacant volume, so to finally open the gate. So we have such kind of like a protocol originally, but downstream people cannot easily understand why more vacant volume should be prepared before coming. This is a very much challenging word. How to estimate total volume? How long lasting flood coming? This is very much like a typical social request, but how to catch up and how to improve our operation. Not operation is, of course, more vacant volume needed. So sometimes we need more dams or dam heightening or to increasing their facilities, more drawdown. Many, many options we should consider. So that's why now is a current topic is main part is disaster prevention, mitigation, and of course, energy transition is very important, carbon neutrality. And impact is the climate change, extreme flood, and also drought. This year, some areas still very severe drought is going. So, but another area, very severe extreme floods occur. Very much like changing conditions. And also, we should more communicate with downstream public. How existing dams is, what kind of capacity, and how to chance to improve something. And also aging issues. But we have a good chance how to invest additionally. But we should explain this new investment, how work well. and what is objectives, not only limited to flood resilience, is energy transition, environmental issues. Many topics should be included, and reservoir sustainability. And also, my topic is also reservoir sedimentation is a long life needed, this kind of existing infrastructures. So the government is now proposing the new policy to basin-wide collaboration needed. And the important point is 3 pillars. One is flood prevention, of course, how to capture the flood in the upstream reservoir or retention area, and exposure reduction, and also disaster resilience to this community. So that's why this kind of 3 pillars should be incorporated. That's why the main topic is by all people should understand these issues and the 2 involved. But today's main concern is how the existing infrastructure can incorporate it for flood protection, flood capturing. But we have many stakeholders or many dam operators, not limited to government-owned, private company-owned, their own purpose, hydropower dams, how to cooperate it, irrigation dams, how to cooperate it, and drinking water supply dams, how to incorporate it. Many different concepts they have. That is an important point. And this one example is during the typhoon Hagibis 2019. One example is Kusaki Dam, belong to the Japan Water Agency, effectively draw down the flood before the coming, and effectively capture the flood water to decrease the flood water flow during the flood time. So this is a good examples. So based on this kind of ideas, this is our project, SIP, and the next one is the bridge, is to increasing this kind of flood mitigation function, both by facility and operational improvement. So SIP is a cross-ministerial approach, is why needed. We have several dams reservoir for flood mitigation, and also our water supply and hydropower. But they have good potential for flood risk reduction, but sometimes cooperation is very limited. But and another issue is uncertainty on the weather forecast. So David mentioned about atmosphere, also how to incorporate it, this kind of weather forecast. And another gap still exists. So how to bridging this kind of, to fill the gap. So this SIP project is trying to increase cross-sectional cooperation. First phase already started, and proposed smart operation using Ensemble rainfall prediction, and applied both to multi-purpose dams and hydropower dams. And now is a second phase. The bridging is the name of bridge topic is expand the smart dam operation to various types of dams. Not only multi-purpose dam, hydropower dams, other type of dams, and making the kind of operation rules. And also today's SIP project is expand this concept to the irrigation dams and all other facilities in river basin. And the key point is how to increasing public acceptance. So important point is prediction is sometimes has an error. So the overestimated issues like a pre-release, to large volume pre-release, but after the flood is water not coming to the 100%, so that they will lose the flood, water volume for the irrigation, drinking water supply, or sometimes hydropower company lose the money. And they also underestimated limited pre-release is maybe more than expected flood coming, overflowing something. Is another risk may occur. Such kind of optimized topics still exist. That's why our project is how to increasing this kind of prediction and how to optimize operation, how to good matching. This is an important point. So important tools is of course Japan Meteorological Agency providing to the public. The GSMS, MSM is like a prediction data. But the important point is a little more longer lead time needs. Usually we already have a 3 days forecast can be utilized as very much like a realistic point. But we need sometimes a more longer period needed for example, because the large reservoirs need more time to draw down, or cascading dams. Upstream dam, second dam, third dam is incorporated, more time needed. And another point is drawdown is with lose of water, but the hydropower company want to utilize the drawdown water for itself with hydropower, so that gradually or more longer lead time needed, such kind of like a drawdown operation. That is an important, interesting point. In that sense, is ensemble prediction data is very much like a powerful and very much fill the gap. For example, typhoon track is coming, generated from the Pacific Ocean, but sometimes 1 week or 10 days later, finally attacking to the Japanese island. So, but still, typhoon track is some uncertainty. So we should show such kind of like several scenarios, and which dam reservoir, how much rainfall actually coming, but still some gap. Sometimes it's 50 millimeter or 100 meter and more than 1,000 millimeter, many variety. But we can show like upper cases and or lower cases and middle cases, and how to matching in the operation will be suitable, something like that. So in that case, this kind of ensemble rainfall prediction data and also rainfall runoff model. And finally, we should show some scenarios. What is the benefit for the operation, for flood risk reduction, and for the energy transition as well. And in the river basin, several dams, how to share this kind of same concept in the one voice point of view. So, and another cutting edge technology is we have cooperated the Japan Weather Association. They have good technology to downscaling to the like GSM model. In this case, we utilize the ECMWF and also some like other JWA cases. And utilizing the machine learning and also deep learning is very much like a quickly to draw down, downscaling to depend on the very much local scaling. The mountains area is sometimes the river basin is very much complex. So this is good to like indicate the actual more precise rainfall prediction. And another case is if this kind of like ensemble data can be provided, how to utilize upper prediction or lower prediction or ensemble mean prediction, which data should be utilized. So for the flood protection point of view, so we can utilize an upper one to reduce the risk. But for the water safe, it is maybe like a drought risk should be considered. So our concept is this kind of ensemble data itself is a good value to optimize these variety values. So a kind of like a sandwich. So the upper water rainfall prediction and the lower one, how to utilize for the to convert to the real operation. So we are selectively discussing this point. And the bridge project is also utilizing not only flood protection. In the normal time, we can keep more higher water level to store more water, and also hydropower production. And also, just after the flood, we are keeping the water and gradually draw down, because we can extend in the 10 days, 2 weeks to the next typhoon is coming, we should quickly draw down. But without any typhoon, we can keep the water, so maximizing the hydropower, such kind. So this kind of like a long-term prediction data is changing our concept of the operation. That is an important like a discussion point for flood risk reduction and how to utilizing the available water. So this is one example is J-Power company, also our partner. They have already good study about the Tenryu River in the middle part of Japan. And we have big dams in the Sakuma Dam. This kind of 3-step drawdown is based on our concept. And utilizing this kind of ensemble rainfall data and gradually draw down like this. And even the hydropower dams can reduce the flood risk reduction, and also maximize the hydropower production utilizing this kind of concept, utilizing this ensemble rainfall prediction. And the last part is our current SIP project. Important point is we already good collaboration with government, multi-purpose dams with a hydropower gun. And still remaining remaining part is irrigation, agriculture sector, and or drinking water supply sector. So we have a good discussion is agriculture sector or the ministry and the institute how to incorporate it irrigation part. So we have defining two parts, upstream runoff area, rainfall capturing area, and also flood downstream area. Of course, we should consider the upstream part first, because rainfall coming, several scenarios, what kind of runoff coming, and what kind of water volumes coming, and what kind of available storage still exists. And if there some shortage, we should triggering the preliminary drawdown to catch the more water. But another case is another point is we should which timing we should release the water to consider downstream like a river channel, and downstream flood area also should take such kind of data. They can take rainfall water with irrigation area, agriculture area with paddy fields and irrigation ponds. And also finally we should utilizing this kind of upstream, downstream data with the operation of the sluice gates and the pumping station, something. So all a system should be incorporated utilizing this kind of rainfall runoff prediction data. So in that concept, we defining this kind of timeline, a kind of timeline. Multi-purpose dams and also irrigation sector should be capture the water, and each three subgroups is starting this kind of study. And the important message is the preliminary studies needed because real-time basis we can utilizing rainfall forecast. But several stakeholders, we should communicate. Real-time basis is very limited. So before the flood, we have a kind of teams or committee. What kind of scenario can be possible, and what kind of action should be taken among each stakeholders. So, and based on this kind of a discussion or agreement, we will really to take this kind of actions in the real-time phases. So this is a kind of concept is two parts, is a preliminary discussion part and also how to utilizing the real-time basis. So we should consider a kind of what kind of rainfall is coming and how to detect such kind of rainfall impact, and to catch this kind of countermeasures. So in that case, since we try to utilize in D4 PDF is a large ensemble data mainly provided the Meteorological Research Institute under the Japan Meteorological Agency. This is originally provided for the climate change impact study. But also we can utilize this kind of what kind of scenario can be estimated in the target river basin. So this is information provided by Professor Sayama. So this is a large ensemble data is what kind of rainfall and runoff will be estimated to each target river basin based on the large ensemble. So this some images. So if we can select one target river basin, is what kind of a critical extreme rainfall is how much return period something. Usually, our concept is based on the previous, like past experience, but in the future, or not experience one, how to estimate the extreme one. This kind of like a scientific approach is still needed. In that sense, this kind of like a large ensemble data is very much powerful to explain what kind of scenario should be considered. Okay, so last point is real-time phases. If we can provide several scenarios, and real-time basis ensemble prediction data is coming, so we try to matching two ensembles, scenario basis data set and also real-time prediction basis. Two ensemble data can be matching, and finally to provide a kind of like or propose a kind of countermeasures. Countermeasure is operation like options. In this case, operation options is, for example, preliminary drawdown. How much level should be drawdown for the considering flood protection? But this is still some like uncertainty exists in the to prevent water loss. So we should consider this kind of risk reduction for the flood and also water usage as well. This is one example. We have several target river basin in the Ano Dam in the Mie Prefecture. Based on the D4 PDF, we have several data sets like this from here to here, the extreme rainfall runoff and also middle flood. And this was a lower scale one. And our target one is a kind of like a middle, a bit large scale flood to effectively utilizing this kind of rainfall prediction data to minimize the flood risk. More extreme one is sometimes it is very much difficult to capture the flood water because of too much extreme. So we should explain what target rainfall or runoff volume will be effectively utilizing the available storage and to catch up the suitable options. And maybe one example is if we can draw down like this, drawdown water level is very much limited. So the flood water is coming large volume and quickly fill the water, and maybe spillway gate should be open very much like fastly, and the downstream impact may be very much like high. But if we can effectively draw down more large volume of water, we can catch the flood water like this. But we should consider that this kind of still uncertainty is if the rainfall is not so much less, how to fill the water again. So we should consider that kind of point. Then the final message is this kind of prediction will be updated. For example, 1 week advance, we can start, but the typhoon track is coming more like updated. We can still keeping or more drawdown, or sometimes we should change the mode to recovering again. This kind of like repeatedly or updated based on the newly updated rainfall prediction data. And this kind of concept is now we are sharing to the among the stakeholders in the target river basin, and this kind of concept can be shared with other countries. Well, this is the example in the Philippines. We have already discussing the same situation. This is the 2020 had the big typhoons coming in the Luzon Island, Cagayan River Basin, and the Magat Dam is belong to the NIA, National Irrigation Authority. And they have already, we have a collaboration with them is the same approach, D4 PDF data set, and also a rainfall prediction, ensemble data, and how to optimize the reservoir operation. Okay, so today's our program is our smart dam operation is important for the ensemble rainfall prediction to utilize. and intensive study this SIP and bridge project, and AI downscaling or D4 PDF large ensemble and matching with two ensemble is very much to showing what kind of scenarios and what kind of countermeasure will be suitable to share with various stakeholders. And this concept can be applied to the other countries, not only Philippines. We are also discussing with Vietnam, other countries as well. So this is our approach. Thank you very much for your kind attention, and maybe later on we will discuss. Thank you very much.